Yeah, good evening, children. The previous class we have studied about important terms of thermodynamics: open system, closed system, isolated system, and what is system, what is surrounding, what is boundary. These all things we have discussed. Heterogeneous system, homogeneous system. Okay, and also we have discussed about what intensive properties and extensive properties. Intensive properties are the properties of thermodynamics which will be independent of mass or independent of quantity, and extensive properties will depend on quantity. That we have discussed the list of all these things. Okay, and also we discussed about the some of the thermodynamic properties, and ratio of two thermodynamic properties will be what? That means extensive property divided by extensive property will be equal to what? Intensive property, that we have discussed. Okay, now we are going to discuss another important topic of this thermodynamics is state functions or state variables. State functions will be there and path functions will be there. PATH, path functions. So what are the two important types here? Important properties: state functions and also path functions. State functions and path functions. The state functions are also called what? State variables. Okay, the fundamental properties which determine, means which will decide the state of a system. The state of a system means initial state and final state. The state of system will be decided by what? The state functions. Okay, the fundamental properties which determine the state of a system are referred to as state variables. Okay, or state functions. Otherwise, we say what? Thermodynamic parameters. Thermodynamic parameters we can say, or state functions we can say, or state variables we can say. Okay, which will decide what? Which will determine what? The state of the system. Next, the change in the state properties, the change in any state property will depend on what now here? The initial state and final state of the system. So the change in state properties, the change in state properties will depend only on what? Initial state of the system and final state of the system. That's all. But these properties do not depend on path of the process. The path of process, they will not depend. They will depend only on what? Initial state of the system and final state of the system. But it is independent of the manner in which the changes or the change has been brought about. Means in which manner the process has been taken place. Okay, these properties will not depend on what? The process of, in which process, in which manner these processes have been taken place will not be decided. These state functions will depend only on what? Initial state of the system and final state of the system. But these state functions will not depend on how the reaction has taken place, how, in which manner the reaction has taken place. Okay, so in other words, what we can say here, the state properties or state functions do not depend upon a path of reaction followed. Any process will have some path, na? Okay, these state properties do not depend on path. They do not depend on path of reaction or path of any process. That's why they're called state functions. Yeah.
So yeah, here we're not talking about states as liquid, gaseous, or solid, right?
So, suppose it's not like this. Suppose you imagine one example. See here. Suppose we have taken one multi-storied building. What is this? Multi-storied building. It is ground here. It is ground, and we have taken multi-storied building here. Now, initially you are here. You are standing here initially. Now, when you go to the top of building, here, okay, at the top of building, potential energy will be same. Initial state and final state. Potential energy will be more in which case? At higher altitude. At higher altitude, the potential energy, suppose X. Okay, and you take this one Y finally. And initially potential energy, how much here? X. Initially, your body has potential energy X on the ground. If you reach the top of the building, it will be having what now? Potential energy Y. Which is greater here? X is more or Y is more? Y is more. That is clear. So this potential energy depending on what now? Initial state of the body and final state of the body. That's all. Suppose now you have gone to the top of building by using staircase. Through steps, by using staircase, you have gone to the top of building, suppose. Then your body will be doing some work now to climb to the top of this building. Your body will be doing some work. Okay, that point keep in mind. That work done by your body is suppose some value. Next, the same person is going through lift. Suppose the same person is going through lift to the top of building. Then the work done by the body will be less or more in the lift.
Less.
Then when you reach the top of building through lift, your body will do any work.
No.
No work will be done. No work will be done by your body. But if you go to the top of building by using staircase, your body has to do some work now to climb. Now the
Yes.
work is depending on the path of this building or not. This total initial state to final state, if you want to reach in this process of climbing, your body is doing more work when you go through lift, go through steps. Your body will be doing very minimum work, very less work when you go through lift. That means the work done by your body is depending on path of process or not. The work
Yes.
done is depending on path na. That's why the path function example, what we can take, the work done will be decided by what? The path of the process. Means the work is a path function or state function. The work is what? Path function.
Path function.
Path. And also we take heat. The work and heat. Heat is given by Q. Heat is given by Q. And W indicates what? Work. The work done, and also the heat absorbed or heat released. The heat absorbed, otherwise heat released, and the work done will be state functions or path functions. What are they?
Path
Path
functions.
functions.
They depend on path of the process. But these state functions, the state functions do not depend on what? Path of the process. Is that clear now? So your body is getting lower energy at ground state and higher energy at the top of building. That is depending on initial state of the body and final state of the body. But the work done by your body will depend on path. That example you can take it.
Yes, sir.
Okay. Now see, following are the state variables. State variables means what? State functions. State variables meaning what?
Depend on initial and final states.
State functions. So these state functions will depend on initial state and final state. That's all. So these state variables that are commonly used to describe the state of the thermodynamic system will be what now? First one, pressure is state function. Volume is the state function. Enthalpy, remember, enthalpy is given by which letter I told you? H. Enthalpy is given by H. And free energy, that is called Gibbs free energy, we say. The scientist name is what? Gibbs. So Gibbs free energy change. Gibbs free energy change is given by capital G. And entropy, remember, entropy is given by which letter? S. Entropy means S. Free energy is what now? G. Enthalpy is H. These all are what now? State functions. After that, temperature. So pressure, volume, temperature. Pressure, volume, temperature are what? State functions. Then internal energy. One more important thermodynamic property, what? Internal energy. That is given by E, or in some books it will be given what? U. Capital U or capital E. Any one letter we use here for internal energy. And entropy means what? S. Entropy means S. And number of moles, small n. So these all are which properties now? Which properties? Path functions or state functions?
State functions.
State functions. So these all will depend on what? Only initial state of the system and final state of the thermodynamic system.
Final state.
But they don't depend on path of system. And remember here, enthalpy is nothing but the total heat content of the system. The total heat content. The total heat content of any system is called what? Enthalpy of system, remember. And entropy means the degree of randomness of system. The degree of randomness of system. Suppose one solid is converted into liquid, suppose. Now, in which case the particles are very closely packed solid,
Solid.
and in which case the particles are randomly moving in all
Liquids.
directions.
Liquids and gases.
Liquids and gases. Now, in this example, now in conversion of solid into liquid, here more randomly or less randomly arranged all the particles in solid.
Less
Less
randomly, uniformly
Less randomly
arranged.
means they are systematically arranged here, fixed positions. They are not random, they are fixed. But here in liquid state, what happened? The molecules are moving here and there in random directions. So now, in which case degree of randomness is greater, liquid or solid?
Liquid.
Liquid. And in which case degree of disorderliness is greater, degree of disorderliness? Liquid only. In liquid only, the molecules are moving in all possible directions in disorderly manner. So degree of disorderliness is more here in liquid state. Degree of randomness also more. That degree of randomness or degree of disorderliness, anyone is called what? Entropy. Entropy meaning what? The degree of randomness of system or degree of disorderliness of system. Anything is called what? Entropy. Now see, in this reaction now, in this solid to liquid reaction, in this process now, what is final entropy? Entropy of liquidities. And what is initial entropy? Entropy of solid. Entropy of solid, entropy of liquid. Now, how to take delta S and entropy change? Entropy change, how to take now? Final
Minus initial.
entropy minus initial entropy. Now, final entropy minus initial entropy will be giving what? Delta S. The change in entropy. Now, tell me, the solid to liquid, if you convert, what is happening to entropy? Entropy increasing or decreasing? Solid to liquid?
Increases.
Increases. The solid, less entropy, na? Less randomness, less entropy. But in liquid, more randomness, more entropy. So in conversion of solid into liquid process, in this liquefaction process, what is happening to entropy value? Increasing or decreasing? Entropy increases or decreases here?
Increases.
Increases. Entropy increasing. So final entropy more. Initial entropy less here in this example. Now more value minus less value. Is the delta S value positive coming or negative?
Positive.
Positive.
That means now delta S is what? Entropy change. Entropy change is becoming what? Positive in this example. Are you getting concept? Suppose you take what now here? Liquid is converting into gas. Liquid is converting into gas. Now in which case, now it is final entropy, it is initial entropy. Now tell me, which entropy is greater?
Gas one.
Gas
Final.
one.
Which one?
Final
Final.
gas one.
Yeah, final
Gas.
entropy there. Now in this process now here, in this process, delta S is equal to final entropy minus
Minus initial
initial
entropy.
Is it positive or negative now?
Positive.
Positive. Okay, suppose if you take reverse process, gas converting into liquid, suppose. Gas into liquid. In this case, final entropy S2, initial entropy S1. Now in this example, delta S what now? Entropy change how much?
Negative.
Negative.
Final minus initial always. Final entropy minus initial entropy. Here final entropy liquid means lesser than gas na? Entropy value. That's why lesser value minus greater value will be negative value here. So delta S value means change in entropy is negative here. Means in this process, what is happening to entropy? Decreasing or increasing?
Decreasing.
Decreasing. More entropy is becoming what? Less entropy. More entropy value is becoming less entropy value. So what is happening to entropy value here? Decreasing. Is the concept clear? So like this, entropy is nothing but degree of randomness of system or degree of disorderliness of system. And what is enthalpy? I told you the total heat content, HEAT, heat. The total heat content of system is called what? Enthalpy. And what is internal energy meaning? The total energy of system. If you take gas, in gas, molecules are moving only in one direction,
All directions.
all directions. So the gas will be having which type of energies? Kinetic energy will be there for gas molecules, plus potential energy will be there for gas molecules, plus rotational energy. Which energy? Because of rotation of gas molecules, rotational energy will be there, and vibrational. Molecules are vibrating also. So vibrational energy will be there. Vibrational energy will be there. Rotational energy will be there. Potential energy, kinetic energy, and different forms of energies will be there. So sum of all the forms of energies of any system is called what? Internal energy. Internal energy of any thermodynamic system is equal to what? The sum of SUM, the sum of all forms of energies of system together called what? Internal energy of system, which is given by capital E or capital U. Remember. Now, next, what is the new word here? Free energy. Which free energy? Gibbs free energy. Gibbs free energy means if your body wants to do some work, if you want to do some work, you have to spend some energy or not. If you want to do some work, suppose gardening work, you have to do, suppose you have to spend some amount of energy from your body, right?
Yes, sir.
So your body should be having some free energy available now inside, then only you can do work. If your body is having some free energy available inside, then only you can do it. Then only you can do some work. So the freely available energy in any system to do some work, the freely available energy available in any system to do some work is called what? Gibbs free energy. Are you getting concept or not?
Yes, sir.
These all we'll discuss one by one later. But remember that enthalpy is the total heat content of system. Free energy is nothing but available
So what is
energy.
difference between internal and free energy?
Internal energy is nothing but sum of all forms of energies of any system together called internal energy. But the free energy is the available energy which can be useful to do some work. This total energy of the total internal energy of the system may not be useful to do some work, but there will be some free energy available that only will be utilized to do some work. Remember, that is called Gibbs free energy, G, given by G. Okay, next. Now, if you want to take delta H of any process, how to take delta H? Final enthalpy minus initial enthalpy. And delta G, if you want to calculate, how to do? Final G value minus initial G value. And how to get delta S value? Final entropy minus initial entropy. And how to take delta E? Final internal energy minus initial internal energy. Like this, the final value minus initial value we have taken. That means every property here is depending on what? Final state, initial state. What do you mean by delta T? Tell me. What do you mean by delta T? Final temperature minus initial temperature. So like this, on the initial state of the system and final state of the system only these properties will be dependent. So about delta V, what do you mean by delta V? Delta V indicates what?
Final volume minus
Final
Final
volume
volume
minus
minus
initial
initial
volume. Like that, we can take the difference of any two values. Final value minus initial value we have taken. This is what now here state functions or state variables. Up to this, clear the concept?
Yes,
Now
sir.
tell me,
Sir.
state functions will depend only on what?
Final and initial position.
Final state and initial state. And the state functions do not depend on what?
Path.
Path of reaction. Now next important word is what? Thermodynamic process. Thermodynamic processes. Now see here, there will be different types of the thermodynamic processes. Suppose here, when the thermodynamic system, when any system, when thermodynamic system changes from one state to another state, let it be initial state to final state. If any thermodynamic system changes from one state to another state, the operation is called what? Process. Which process? Thermodynamic process. That process is called what? Thermodynamic process. Okay, there will be different types of thermodynamic processes. There are what? Isothermal process. First one is what? The first thermodynamic process, what we are discussing now? Isothermal process. Iso means what? Same, constant. Thermal means what? Heat. Thermal means what? Heat. Okay. So in this, what here? Isothermal process, what will be constant yet temperature remains fixed. Fixed means what? Constant. So what is constant in the isothermal process? Temperature remains constant. So what I have to define this one? The process means the thermodynamic process is termed isothermal process if temperature of the system remains what? Fixed. Temperature of the system remains constant. That is, operation is done at constant temperature. Operation means it may be conversion of liquid to gas or gas to solid or solid to gas, anything, any conversion. If it takes place at constant temperature, that will be called what now? Isothermal process. Okay, and this can be achieved. This constant temperature can be achieved by placing what? The system in a constant temperature bath. In a constant temperature bath. Bath means what now here? It may be any container in which the temperature is maintained at fixed temperature. Any container in which the temperature is fixed is called temperature bath. So in the constant temperature bath, we have to place the system. Then the system will be at constant temperature. And the process now is called what? Isothermal process. That is the type of constant temperature bath is called what? Thermostat. So what is example for constant temperature bath? Thermostat. Thermostat. Okay. Suppose when you are doing iron, when you are doing ironing here, ironing of shirt, there will be one knob, right? To fix the temperature of the iron. Iron box is there, na? Iron box.
Yes, sir.
In the iron box, there will be one round circle, no? Means adjusting temperature. To adjust the temperature, there will be one knob here. That knob is nothing but thermostat. It will maintain what? Fixed heat. Okay. So as this thermostat, we have to place what? The system. The system will be called isothermal system. And the process name is what now? Isothermal process. So for an isothermal process, what will be zero here? Delta T will be zero. What does it mean here? Delta T, or what they wrote here? DT. Delta T. The difference in temperature, that is what? Final temperature minus initial temperature is what? Zero. Why it is zero? The initial temperature is same as what? Final temperature. So initial temperature, suppose 25 degrees and final also 25 degrees. Temperature remains constant. So 25 minus 25, how much? Zero. So the delta T will be zero for which process? Isothermal process. In any problem, in any numerical problem, if you come across isothermal process, immediately what you have to recall? The delta T value, zero. That is, the heat is exchanged with the surroundings and the system is not thermally isolated. Now, when temperature is constant, don't feel that heat is not exchanged. When temperature is remaining constant, what is happening? The heat is getting exchanged with surroundings. From system, some amount of heat is exchanged with what? Surroundings. That's why the temperature is remaining what? Constant. And now the system is not thermally isolated. What is thermally isolated system generally? Thermos flask. Thermos flask is what? Thermally isolated system. Here, when temperature is remaining constant, the system is not thermally isolated. That means what? Only remember that delta T value, final temperature minus initial temperature will be zero, and heat will be exchanged with the surroundings, and the system will not be thermally isolated. These points you have to remember in isothermal process. Next. Now, next process, what is the name given? Tell me. Adiabatic process or adiabatic process. Adiabatic process or A silent reaction. Adiabatic process or adiabatic process. So in this process now, delta Q will be 0. That means what now here? Delta Q means what? Final heat minus initial heat is equal 0. Why? The quantity of heat will be same initially and final. That's why Q2 minus Q1, final heat minus initial heat of the system will be 0. That's why delta Q will be 0 in which process? Adiabatic process. And in isothermal process, what will be 0? Delta T will be 0. So whenever you see these words, immediately you have to recall this. See here, if a process is carried out under such condition that no exchange of heat takes place. Here,
Sir, so wouldn't all isothermal processes also be adiabatic processes?
no, how? See here,
Processes.
isothermal condition, what tell me? In isothermal process, heat is exchanged with surroundings.
Oh,
But you see, in adiabatic process, check it here, no exchange of heat takes place. No exchange of heat takes place in what? Adiabatic process. But
So
in
what if heat is not exchanged, then how temperature can vary?
no, temperature will be
it
varying.
might vary within the
Here,
system
heat-
itself, but
heat
there
is-
is no change
Heat is
outside.
not getting exchanged, meaning what? Heat, no exchange of heat, meaning what? Temperature will be changing. If whenever heat is getting exchanged, temperature will be remaining constant. Remember, our body temperature will remain constant because in summer season, our body will be absorbing heat. And in winter season, our body will be emitting heat, so that it will be maintaining some temperature, constant temperature. So whenever heat is exchanged, temperature of system will remain constant. Whenever there is no exchange of heat, the temperature will not be constant. So in adiabatic process, delta T is not equal to 0. Remember, delta T is not equal to 0 in adiabatic process. Okay, what will be 0? Delta Q will be 0. Final heat minus initial heat will be 0. Is that clear, ma? So in the adiabatic process, no exchange of heat takes place between the system and surroundings. This type of process is called what? Adiabatic process.
So
And-
it's like how a thermoflask works. There's no
Thermoflask.
exchange of
Yeah. In thermoflask, the same concept will be there. No heat loss will be
Okay,
there,
sir.
na? Like that. See now, the system is thermally isolated. Thermoflask is example for our isolation, na? Thermally isolated system. But here, the system is not thermally isolated. The system is not thermally isolated in isothermal process, but in adiabatic process, the system is thermally isolated. Is the difference understood here? Next, see here, this can be done, means this delta Q remains 0. This can be done by keeping the system in an insulated container. Example, what that is? Thermos flask. By keeping the system in thermos flask. System means what here? Hot milk, hot tea, anything. Okay, by keeping hot milk system in thermos flask, we can maintain what now? Adiabatic process or isothermal process? Adiabatic process. So in adiabatic process, the temperature of the system varies. Means temperature of system changing means what? Temperature of system varies, meaning what? Delta T is not equal to 0. Did you really understand about the isothermal and adiabatic process?
Yes, sir.
Next, now see isobaric process. Here bar is the unit of what? Pressure, na? Isobar means what will be constant? Pressure will be constant. Here what is dP here? Delta P. Delta P meaning what? Delta P means what? Final pressure minus initial pressure of the system. So this delta P is equal to what? 0. So the process is known as isobaric process, in which the pressure remains constant throughout the change. Throughout the change of the process, the pressure remains constant. That is delta P is 0. Next, isochoric process. Core means volume. Isochoric process means what will be zero here? Delta V, that is equal to final volume of system minus initial volume of system is equal to 0. So the process is termed isochoric, in which volume remains constant. Means there is no change in volume. Initial volume and final volume will be same. That's why delta V becomes 0. So throughout the change. Are these two steps understood here? Two processes, isobaric and isochoric. So far, how many processes we studied? Four thermodynamic processes. What are they? Isothermal,
Isothermal,
adiabatic,
adiabatic, isobaric, and isochoric.
isobaric, and isochoric. 4 types. Next, cyclic process. Which process? Cyclic process. Suppose
Which process?
one system is taken here initially. It is going to some other place, some other state, again going to another state, again going to another state, and finally coming back to same state. Initially one state to other state going, second state to third state going, third state to fourth state going, again fourth to one is coming. This type of processes. Again the system is reaching what? Initial position. So cyclic process, check it here. When a system undergoes a number of different processes, here 1 to 2 one process, 2 to 3 one process, 3 to 4 one process, 4 to 1 process, another process. So when a system undergoes a number of different processes and finally returns to its initial state, finally the system is coming back to its original state, initial state. Now initial state is this one, final state also this one. Initial state is this one, final state also this one again. So it is termed as what now here? Cyclic process. So when a system undergoes different types of processes and finally returns back to its initial state, that process is called what? Cyclic process. For a cyclic process, remember, dE is 0. What do you mean by this one? Delta E. E means what here? Which energy? What is E here?
Internal energy.
Enthalpy or entropy or internal energy?
Internal energy.
Yeah, internal energy change. Internal energy change. Change means what? Delta na here. So internal energy change is equal to what now? Final internal energy of system minus initial internal energy of system. This total value will be 0 here. Means difference will be 0. Means initially how much internal energy is there. Finally also same internal energy will be there because the system is coming back to its original state now. That's why. Is there any change in initial and final energies here? Internal energies? No. That's why delta E will be 0 here. For which process? Cyclic process.
Cyclic.
Next, delta H is 0. What do you mean by delta H?
Enthalpy.
Final enthalpy of system minus initial enthalpy of system also will be 0. What is enthalpy meaning here? The total heat content. The total heat content of system initially
Content.
and the total heat content of system finally will be same here. That's why again what now here? This delta H will be 0. In which process? Cyclic process. So whenever you see the name of cyclic process in the question, immediately how to take delta E 0, delta H 0. Is the concept clear up to this? Next is here.
Yes, sir.
Next, reversible process. Reversible means what? The reaction will go in one direction, again will come back in same direction. That is a reversible process. So a process which occurs infinitesimally slowly. So reversible process, slow or fast process? Slow process. Infinitesimally means very slow, very slow. So a process which occurs very slowly, that is opposing force is infinitesimally smaller. Opposing force is what? Very smaller. So when reaction is going on like this here, it is driving force. Driving force. And opposite what will be there? Opposing force will be there. Opposite which force will be there? Opposing force will be there. It is driving force. It is opposing force. Now see here, opposing force is very smaller, very larger here. Opposing force is infinitesimally means
Smaller.
very smaller than driving force. In which process? In reversible process. And reversible process slow or fast? Slow. And when infinitesimal increase in the opposing force can reverse the process, it is said to be reversible process. When the process will be reversible here? When the process will be reversible? When increase in the opposing force, when increase in the opposing force can reverse the process. Okay, suppose initially the reaction is going left to right. It is driving force going on like this here.